All right, before we begin, any question about anything? Start recording. Any question about anything? Questions?
Question about milestone one.
Mm-hmm.
Because we revamp for the copy and copy assignment,
Mm-hmm.
so do we need to write implementation for that's why we should write them in the header file, like we should write the function in the header file. After that, we equal to delete.
Yes.
Yeah. Or
If
we
you're
need to-
preventing, if you're preventing, just write equal to delete.
Yeah. We don't need to write the implementation in the implementation
Nothing,
file.
nothing. When you want to prevent, okay, as I mentioned, it depends if we are doing old way or new way. If it's old way, to prevent anything to happen, you create either assignment operation, any kind of construction, anything that you want to prevent doing, you simply, in old way, you simply implement it, write the prototype inside the private part, and then in CPP part, you write an empty function. But new way, you don't do that anymore. You just write it in a public part, and you write equal to delete in front of it. And that prevents it. So that's the prevention. You can do both ways. It doesn't matter, but I rather you do the new version. Be aware of the old one, but do the new version. Anything else? Yes.
On the instruction, is it for like milestone one? Is due on today midnight, but is this format is rewarded if it's submitted within 1 week late?
Yeah. So essentially, all milestones except 5, milestone 1, 2, 3, and 4, the due date is your target. If you are even 1 week late, you get the full mark for it because it's the implementation period.
So even if we're late, it's assigned to within 7 days of late. Is format.
Yes. So you have to submit it anyway, which means if at the end of the semester, by the end of the semester, you do not submit any of the first 4 milestones, your mark for the project is 0. You have to submit it. But to gain the full mark, you cannot be even 1 week late. It doesn't matter. So essentially, the due dates that I'm putting for you is like showing you not to procrastinate, letting you not to procrastinate, to kind of set due dates. It's supposed to be done almost at this time, and the other one almost at next time. So you just keep track of your time using that.
Okay.
All right? But final what? Milestone 5, that's not the case. For milestone 5, you have an exact due date, and every day 10% lower for each part of the milestone. So milestone 5 has total of 6 submissions. If you just submit one of them 1 day late, then 10% of that will go, which means you get 9% on one of them, and the rest will be 10. And it's as simple as that. Each one of them is 9%. And the total thing for the project, I think, is like 9%, so it's not that much. But that's how it's done. There are no more extensions for anything after the midterm. So you miss a workshop, you miss it. You miss a citation, you miss it. Unless I tell you beforehand and before due date you resubmit. So if I send you a message that the citation is missing and you submit it before the submission is closed, you're fine. But anything that you do that causes the problem with the workshops, no more extension. Extensions were, I always do it at the first half because you are trying to find your footing and try to catch up. After that, everything's precise. And for project, there are no extensions whatsoever. Now, of course, you may get sick. Something might happen. Those extensions still exist. So if there is some dire emergency, you're sick and things like that, you can't come to school because you're sick, so you cannot submit it from the lab. Things like that, you simply ask me and you get your extension. There's no problem. But extensions, because I didn't have enough time, because I don't know. It's like just, anybody asked for extension, I gave it for the first half. Second half, it's not going to happen. Okay? Remember that. Any other question before we continue? Marks, by the way, today is 9th. By tomorrow, today is 9th. By tomorrow midnight, any objections or anything after that, all first part of the semester marks are finalized. You cannot change it anymore. Okay? So if you have any objection to any mark or any concerns about any mark, you have to talk to me tomorrow. Okay? Or today. All right. If you think there is not enough time, I can give you 1 day extension, make it 11. Anybody wants me to make it 11? Or tomorrow's? Huh? For discussing your first semester, first half of the semester marks. We already talked, you and I. Why you want an extension for it? You're done. Why? You just want extension is good? Let's get it. You and I had to talk. We went through it. Everything's good. Okay, no, so, no. Can we make it 11? The person who doesn't need it is asking for it. Anyways. So, you have your name up there, so you know who's going to answer the question again. I wanted to pass this around, but I don't know. If the next person over there, claim your microphone, please. Okay? So, Judy, do you remember the 3... Why are you laughing at me? Okay, so we had 3 pillars of object orientation. We said for an application to be object-oriented, 3 different things must exist. 3 different methodologies must exist. What is the first one?
Encapsulation.
So encapsulation is the very first one. Okay? Ian, what is the second one? Inheritance, sure. Inheritance is the second one, obviously.
I only know the 3 of them. It's just I do not know the order.
Hello. So encapsulation, inheritance. Now take Google it quickly. Yeah, that's perfectly. It's not guess. It's a perfectly correct thing. So polymorphism is the second one. So the only person's voice who got recorded was Julie. The next of you is going to be just muffled voice. Okay. Okay. So we know it's encapsulation, inheritance, and polymorphism. These are the 3 things. We added a 4th thing that we said this is not part of object orientation. You need to have this skill to be able to write any program. Do you remember what was that? Is Edward here? Edward? Not here? No? How did I make it absent? I forgot.
Plus, maybe plus.
Oh, yeah, plus, you're right. Thank you. Okay, Mohammed, you're here? Mohammed? No? Timur? I know. You're absent. Chan, okay, there we go. It's your turn. Your turn. Abstraction. Yeah, and what's abstraction? You remember kind of what it is. It's not hidden behavior. It's something else. Zina. Not in? Zina? No? Are you in? No one? Wow. IHAP or EHAP, I don't know. Shwanan? In? No? Wow. Gary, Right? Is it the same class?
It is the same class. I'm in your class.
Huh?
I'm in your class. That's
I
the
know, I
reason.
know. So, no? Oh, yeah, you're here. Okay, good.
That's the long
Next
name.
next time, it's not as long as mine, trust me. Okay, so,
Yeah, you.
okay. So abstraction, what was abstraction? Remember? Removing unnecessary, actually, I never used that phrase. That's perfect. Removing unnecessary details. That's perfect, actually. Yeah, removing unnecessary details so you can think. If you don't do that, you're gonna keep going back and add lots of complications that are not needed. Okay, so you have to always, and that we need to do in any type of thing. Okay, so Jamie, you're here? Oh yeah, there you go. Sorry, sorry, I'm very bad with names. Oh, so only Jamie and Judy are the people with the audio being recorded. Hello. All right. So, Jamie, do you remember what encapsulation was?
Include method and attribute.
Putting the data and behavior together, attributes and methods together. So attribute, method, data, behavior, okay? So putting the data and behavior together. Have we covered that? Did we study that down to this point? Have we covered that?
Yeah.
Yes, we did. That was a thing. We created a class, we made it private, we made it public, all those things, we put it together, life is beautiful, and yada, yada, yada. Okay? So now the next thing was inheritance. Roberta? Okay. Inheritance. Do you remember what inheritance was? Inheritance was to, no. Inheritance was to, Jackie? No? Ahmed? You're not Ahmed, you're Ian. Okay.
I know the answer.
I know you know the answer. Many people know the answer. Ahmed? Now here. I just want to get to the end of the name, then I'm going to ask myself. Victor? Not here? Seriously? Mert? There we go. Hello. So inheritance, do you remember what inheritance was? Or what is the purpose of it at all? You don't have to be technically correct in phrasing, just whatever comes to your mind. Nothing, absolutely nothing. Okay, yeah. Yohao, you're here? Mark. All right, there we go. Parent and child. Okay. Actually, that's one example that is not really inheritance. It's a very bad example of inheritance. Remember about, so inheritance is essentially having a design and use that design to build something new. We talked about having a bicycle and making a motorcycle out of it. And we said motorcycle is a bicycle that has an engine. So you essentially build on your last design. Yes?
So basically, you're like borrowing previous similar function structures.
It's implementation I'll talk about. I want to talk about the idea. So inheritance, it means you have a design, you make a new one. Parent and child, although it's used a lot, so they use parent as the base class and child as the derived class, because in biology, I take my features from my mother and father, so they call it inheritance, but that's not the case. We said that parent and child are actually objects of the same type. They are inherited from mammals, but they are not. Parent and child are not. Parent and child are actually two objects of the same class, human being, right? Right? Yep. So we gotta have that clear. Have we covered that inheritance in this class? Yeah. No, we didn't. How do you do it? And how you get good marks? You give me wrong answers. Okay, so we haven't covered that. We don't know how. we actually can do it, okay? Now, talking about polymorphism, Jonathan, you here? Okay. Polymorphism, do you remember what polymorphism was? Many forms. Good thing you translated the word, but what does it really mean?
Subclass can take instances of like a superclass. Like
No, that's inheritance. This, a subclass takes instances of the superclass. Thank you for the Java explanation. But it is that's inheritance. Polymorphism was many shapes, which means doing the same thing in different ways. We kind of gave examples for it. We gave examples of two specific ones, and we said these are fake polymorphism. These are not really polymorphism. One of them was casting. So when you say A plus B, one is double, the other was int, it knows how to do it. It casts one to the other and does the addition. So that's polymorphic. Then you can say plus between two integers. It's still plus, but it knows how to do it. So all these things are happening by casting. It's polymorphic, so we have done it. We know what it is. Also functions with different arguments. We said that in C language, I have a function with one, I cannot have two functions with the same name, but in C++, I can have functions with the same name, but their arguments are different. And it recognizes which ones they are calling using the argument. Then we said, but that's not really polymorphism, because if I have a function foo with an int and a function foo with a double, what the compiler does behind the scenes kind of adds the argument types as a suffix to the name. So the first one becomes foo underline int, the second one becomes foo underline double. So it's not really the same name. It's kind of faking it. Okay, we're gonna learn real polymorphism soon. It is in the category of polymorphism, but it's not universal. This polymorphism is what we call ad hoc. It's a polymorphism that, with closer scrutiny, with closer look at the thing, the polymorphism fades. But from afar, when you look at it, it looks like polymorphism. Okay. So talking about inheritance, how do we implement inheritance? What is the syntax of inheritance? The syntax of inheritance is, as I'm going to explain now. All right. I am trying to, these days, anyone from my heritage is extremely nervous. Because my mother home, I haven't been Iranian for 30 years. I've been Canadian most of my life. But I have a cousin who's dead, shot in the head in Iran. I have relatives that are in prison, and I have the country's being bombed, and people are dying in thousands. So our mind is always confused. So my apologies if you see me, I am cuckoo. That's the reason for it. I apologize for it. But that's how it is. We are like this for now, but hopefully it's going to be good soon. It's sorry to tell you this, but it's like my country is like it had cancer. Now it's in chemotherapy. So it's going to hopefully be good after this. Anyways, so how do we implement inheritance? Let's say I have let's actually put it here. a class, and I call that class a line. So when I instantiate a line, I specify what is the length of the line, and I'll tell to line to draw itself. And a line will draw itself. So that's what a line is. And I can implement it very easily. So when I say I want to set a line, I'm going to say, obviously, a line has a length, right? That, say, by default is, I don't know, 0 in length. Okay? And I'm going to have a line that by default, it's what it has. So because I initialize that, I don't need to mention anything. Okay? And then I create the line with a length. And that length, I did not show you this. I did not show you the syntax. I can initialize the values inside a class in the initialization area. So now in here, so I'm just going to write it like I'm going to do inline coding. So if you put it outside, it has to be outside. Let's put it here. I just want to show it to you. So if I create the line over here, line size t length, then in here I can actually say m len, and I can initialize that with length. And I don't have to write anything anymore in here. If you do it like this, then you are initializing the length, which another one, you're here. Yes. So what is the difference between initialization and setting? Do you remember? In general, not with this respect to this code. In general, when I say initialize and I say set, I can say set the integer to 10. Then I'm going to say initialize the integer with 10. What's the difference between the two? Do you remember? Yes, that's initialization. Okay. Okay. He's initializing his nose. Okay. You were saying? Defining the variable. Assigning. So when we say, actually, that's a good terminology too. So when I say defining a variable, essentially it means, let me put it over here. It doesn't make sense. That's sitting in front of you. So essentially initialization means creating a variable with some value in it, which means when the variable comes, not variable, anything, when the object comes to being, it has the value in it. It never has any other value in it. When you are writing over here like line 20, then the compiler creates m length with 20 in it. It will not be first 50 or 0 or garbage and then set to 20. Okay? You understand? So what is that? So, but this one is doing initialization too. So which one is what? So if this is doing initialization, how about this one? When you write an initialization here, it overrides that one. It ignores this one. This initialization only happens if you don't mention how. Okay? So this initialization, so this is essentially initialization. I'm going to bring it down for you just to see. So this initialization overrides the inline one. Let me do it like this so I can. Okay? So this overrides that one. Okay? Which means this is not initialization. Okay? Which means first mlen becomes 0, then that 0 will be overwritten by length. Do we understand? This looks like what the heck you're talking about. The outcome is the same. Why you're bothering us? The difference is that when anything you're doing like that, when anything is built, it has an original attribute. You are building a wall, you put a drywall on. By default, what is the paint? White, correct? So that's initialization, which means this thing comes in white. There is no other color in it. In computer programming, that's not the case. If I get an integer, if I create an integer, if I don't initialize it with anything, it will have some random number. It's as if you go and buy, we don't have that in real world. In real world, anything that you get, it has a default value in it. You get a mug, it has a color. When you get a cell phone, it has a brand. Everything comes with whatever. In computer science, that's not the case. When you create an integer, there's a random number in it. Now, if I don't want a random number in, I initialize it. Do we understand that? Okay. Now, if I do not mention this over here, that's what happens. M length inside line gets created with some garbage value in it. Absolutely garbage. So if these two, they both can exist. You know that. I'm going to wipe one out because they are identical. Okay? But if I write the constructor like line 11, because constructor's job is to build a line, correct? When it wants to build the line, it builds mlen with the length that is receiving in it. Mlen will never exist with garbage in it and then overwritten by something. This is the value that initializes it. But if I write my constructor as line 13, because I didn't mention m length and I did not initialize it here, first mlen will get created with some garbage in, then that garbage will be overwritten by length. Do we understand this? Okay, which brings us to the next thing that I'm going to show you later on. So I'm going to remove that because we know that initialization is there, but because I have a default, I need to put that one. If I want the default not to be like this, then I actually have to implement the default too. I have to say line, and in here I'm going to say m length 0. So here I'm doing initialization in old ways before inline initialization was permitted. C++ did not have inline initialization permitted a few years ago. They added to it. Now we can do it over here. But again, if you have it over there and have it over here, this overrides the other one. Always remember that. Okay? We're good? All right. Ian.
I just want to say you can use Jade as an example, like where instead of Jade there might be impurities or cracks, which can be represented as the random number.
Okay. I'll remember it next time I'm teaching this.
Yeah,
Okay. Okay.
I was looking at you and you
Okay.
cannot think of anything.
But anyways.
I saw Jade.
All right. So, but let's get on with this thing. So for now, I create the length, and length is being set. Yes.
I have a question. How can we make sure that the length is valid?
Hmm?
How can we make sure that because we
How can you make sure it's valid? First of all, you can write a conditional expression over here. It's an argument you're passing. You can have a validation function called that validation function here. So let's say int correct length. Oh, it's not int, size t. Okay, and in here I'm going to say if len is greater than 80 or greater than 79, make the length 79. And I'm going to say return len. Are we good with this? Now in here I'm going to say correct length. Happy? Okay, so you can initialize it if you want. Are we good? Okay. All right. That's why the code for each class changes. Somebody asked a question, probably in NAA, this is not going to be there. Well, we'll see. Anyway, so we get down to this point. You're noticing that I'm not in rush to teach what I'm supposed to teach this week, because I want the basis to be strong. When I'm actually getting to it, we understand what the heck is going on. Are we good down to this point? We good? Yes.
Can we call the function that is inside the class like the way you did?
Here? Yeah, this one and this one, they are not different. They are the same. The reason I brought it out, I want you to see, let me actually put the other one in. I want you to see that how it happens if I write it outside of the class. I just wanted to show you different syntaxes. So in here, I can do line over here, and I can write over here m length. And by the way, you can put curly brackets over here too. Curly bracket, you know, it's universal. It's the same way. And then I'm going to make it empty. So I could have done it like this. I don't know what, see? I could actually write it over here or over there. The reason I wrote it outside, I just wanted to show you that if you want to initialize it, it cannot be on the prototype. It must be where the function is being implemented. So the initialization area cannot be inside. I cannot initialize it at line 11 because line 11 is not where it's being implemented. Where initialization happens is where the function is being created. If you do it in line, you can do it. You see that empty thingy that I have over there? That's implementation of it. Do you understand what happened? Hopefully.
Yeah, but I was asking about when you called correct length.
Yes.
That is outside of the class.
No, it's inside class.
No,
It's a member of a class.
and you're calling it on line 15, is it?
Yeah, it's not outside of the class. It's inside the definition of the function. This is my function. I'm building my function. It's inside. So anything after the close parentheses is inside your class. It's within your scope of your class. A perfect, actually, very good question. Yeah. Okay. I could not put it here, but I can put it here. This is function prototype. This is implement. After the closing, everything's implementation. So it's part of the scope of the class. Are we good down to this point? We okay? All right. And obviously, I need to be able to tell it to draw itself, so I'm going to say draw. And this draw is not going to change the thing, so in here I'm going to say for size t, I set to 0, I less than m len, and I plus plus, and see out. I'm going to draw it with a dash, so that's my line. Okay, and see out. Are you okay with this? So this for loop of mine doesn't have a body, so I can put many stuff at the not the middle, but beginning and end. I can put anything I want. I can separate it with commas. So what I have written over here is equivalent to this one. So this is the same as potatoes, potatoes, same thing. No difference, okay? Actually, wrong. Absolutely wrong. Now it's potatoes, potatoes. Okay? Because whatever you put at the third thing is the last thing that is happening in the loop, right? So I have to put the C out at the other side. Now these two are identical. Okay? Anyway, so it's drawing itself. So now I can create over here a line. I can create over here a line L20. And I can say L.draw. And I run it, and it's going to draw the thing. That's my line. Are we okay with this? Are we okay? Okay. Now, let's say I want to create a bar chart. What is a bar? You know what a bar chart is, right? They draw bars based on the value of different things and they compare it with each other. Bar chart is essentially a line that has a type. It's an array of bars. A bar chart is an array of bars, correct? So you have a bar in it, and that bar of yours has a title and a value, correct? That's essentially what a bar is. So if I want to create a bar, how do I say it in English? I say bar is a line with a title, correct? Whenever you hear this phrase, is a, and you're going to learn this in your system analysis courses, when you're actually designing stuff, it's called use cases. So you go interview the person who wants a system that for you to design. The system, and you write down their requirements. In the requirements definition of the application, whenever you have is a, that means inheritance. Okay? So a bar is a line with a title. A bar chart has lots of bars. So a bar chart is not a bar. It has bars. That's belonging. That's attribute. It means bar chart has attributes of type bar. But when I say bar is a line, that's inheritance. How do I do that? How do I actually create a bar so I don't have to reinvent the wheel and create a line? This is what I do. I'm going to say over here, class, bar, public, line. Now, bar is a line. It has everything that a line has. Everything, okay? So, so essentially, what I can do over here is start building it. So if I want to create a bar, what happens over here? So I want a bar to get, how do you want a bar to get created? First of all, a bar must have a title, correct? So I'm going to add one thing. I don't need to add any length. Anything that a line does, ignore, because it comes with it. Okay? Now I'm just going to add what is needed to be added to a line. So all I need is a title, correct? So in here, I'm going to create a title. So I'm going to say character, title. And in this character title of mine, I'm going to say, I don't know, hopefully not more than 20 characters. So not more than 20 characters, right? And I'm going to create over here a bar. And this bar of mine has nothing. So in here, it only has constant. Oh, I have to fix the title. Title. Constant character. Pointer title. It cannot do a default value, and that's it. Okay, so that's what I'm going to do. And when I just create a bar, it's going to have a title with nothing in it. So the length of the thing will be 0, as we designed over there. Now I want to have a bar with a title and a value, correct? So now in here, what I'm going to do is this. I'm going to say bar is set to. Actually, I'm going to add one more thing to the line, if you don't mind. I'm going to add a line. It takes 2 seconds. Line reference operator equal size t len. And in here, I'm going to say mlen is set to correct line len. And I'm going to return this. In case somebody wants to change the length, they are able to do so. We good? Okay. In 2022, you can collapse these things. In here, you can't. It's interesting. I don't know why it doesn't allow me to collapse these. Anyways, so now I'm going to say I'm going to have a bar with a title, constant character, pointer, title, and what else? Size t length. Okay? Now, to create this, I have, if you don't, let's put it like this. When you are writing a constructor, if you do, first of all, this title thingy, let me just set it up. I think for this, we're going to need that str thingy that we had. Let me just bring it quickly from the previous notes. I think it was here somewhere, str. I'm going to copy that and bring it to our notes so I can do string stuff. So let's add this. Okay, so I have the C string. So in here, I'm going to say include, I'm going to say using namespace, seriously, using namespace Seneca for that std thingy, and I'm going to add it, include csdr.h. Okay, now let's continue with this. So if I want to create the bar like this, I'm just going to add the title over here. Which is just an str copy into title from title up to 20 characters, right? So that's the str copy. It just copies the title in there, okay? So I did not mention in line 31, because think about it. When bar is getting created, you are creating a line 2, correct? Line is part of bar. So when it's being built, line will get created too. In this constructor, did you mention how to create the line? The answer is no. When you don't mention, the line will be defaulted. So because we didn't mention how, since the line is not set, is not because the line is not initialized, it will be defaulted. Which means if you do not have a default constructor in line, this will fail. It's going to tell you, hey, you are creating the bar, line doesn't have a default constructor, I cannot create it. Are we good down to this point? Are we okay? All right. Now in here, I'm going to change it. We learned that we can actually initialize values over here. I can actually initialize stuff when I'm actually creating them over here, right? On purpose, I'm not initializing the title because I want everything to be there. So in here, now, we know that bar has line in it, correct? So in the initialization area, you can initialize the line part. So now in here, I can say line, and in here, I'm going to put length. And then I'm going to write in here length. Why is it giving me an error?
This type of website T. Yeah, that one. TH.
Oh, I seriously can't see that. Can you believe it? Okay, so now in here, I'm going to say str copy into mtitle. Title and 20. Okay? So as you see, the default construction is just setting the title and says, I don't want to do anything to line because how it's being defaulted is good enough for me. But in here it says, when you are creating the line, pass the length to it. So first line will be created with that length, then title will be set. Now, if you just be done with it as is, in here, instead of line over here, I can create something like this, bar B, Barbie, okay, okay, and in here I'm going to say nothing. Now in here I'm going to say bar B2. In here I'm going to say something. And I'm going to put a 50 in here. Now I'm going to say B1, B, draw, and B2, dot draw. I did not implement any draw, but because the base class has a draw, it will call that one. As easy as that. So when I run this, you will see it's not going to make much sense because I didn't do anything to draw, right? I just, so essentially nothing will print nothing and the other one will print the line, but no title for it, correct? So what I need to do over here is override. I'm not saying overload, I'm saying override. Understand the difference between the two. Overload is to recreate a function with the same name and different number of arguments. Override means creating the identical method in a child class, in a derived class. So now in here, in my B2, in my bar, I'm going to create the exact same thing. So what do I need to do in this draw? I need to first show the title, correct? So in here, I'm going to say cout title. Not like that. Title. and say I'll do something like this, and I go to new line. Now, what do? Do I put a for loop and print stuff? Actually, I can't. Why? Because line's length is private. Although bar has inherited all the stuff from the line, but it doesn't have access to its private parts. It only has access to its public parts. So what can I do? I have to explicitly call the draw of the base class. So in here, I'm going to have to say line. As you see, this is a class name. It's not an object name. And class names use scope resolution to access the part. So in here, I'm going to say scope resolution, draw. So I'm saying the draw of the bar first prints the title, then it calls the draw of the line. So I improve the draw in my bar. If you look at the bar over here, when I run it for the second time, it says nothing, and nothing is printed. It says something, and something is printed now. Now I can go to next step, creating a bar chart. And in that bar chart, I can create an array of bars and do whatever, or dynamic array of bars if I want to, and create a bar chart for myself. I'm not going to go there. I just want to teach inheritance down to this point. If you want, you can later on, actually as practice, continue the bar chart thingy and make a bar chart out of this. So down to this point, as you see, I just wanted to show you the syntax and get you familiar with different things. So use the terminology properly. Don't say bar calls the constructor line. It invokes it. It doesn't call it. So in here, bar is not invoking any constructor, which means the parent will be defaulted. In here, the bar is invoking the line. It means before creation of bar, length will be created with the length value. I'll walk through for you in 2 seconds. Okay? So let's walk through it. I'm just going to go through it step by step. Whoa. And let's get over with this thing quickly before we continue. You're here? Sonia? Lance? Ilian? Thank you. Carlos? Thank you. Barbot? Thank you. Thank you. Thank you. Alexander. I would really love to meet Alexander. Perfect. Thank you. And we're done. Okay? Much appreciated. So now we can actually continue with the thing. All right. So let's do the walkthrough. What's the time? 12:42. Class ends at 1:25, right? So we'll end at usual as you. We're going to end 15 minutes early, and you're not going to get a break because I have to run to the other class, to the other building, to K building. Okay? So 1:10 we'll finish it, which is in approximately 20 minutes. Set an alarm at 1:10.
All right, your alarm set for 1:10 p.m.
Okay. So please, these mornings when you're coming, come with a coffee. I see half of you are going like that. Okay. I have to save time so I can run to the other class. Okay, so let's actually do it like this. Put it over here. That goes to left, and this goes to right. Let's walk through. Oh, really? Okay, there you go. So it's created. Now in here, as you see, because I'm not mentioning how to create it, it goes to the constructor, but then it jumps to the default constructor of line because I didn't mention. Always the base class must get created for the derived class to be. It's like you are creating a two-story building. The first story, the first level must get created to go to the second one. It's exactly the same. So first it creates and defaults that one, and then it sets the title to whatever it is. Now, in the second one, again, it goes to the constructor, but before it can build it, it needs to build the line, and it's build the line with the correct length being set. And then it comes down, then it comes to bar and builds the bar. Then it comes down over here, it says draw, it draws. First it prints the title, then it draws the line, which is nothing. Then for the second one, first it draws the something, then it goes to draw of the parent and draws everything. Shift F11 comes out and draws everything and comes out. Okay? Again, terminology. Explicit call to a method of a class. Scope resolution happens when you want a class's thing to be called. It's not a dot anymore. Dot is for objects. Scope resolution is for classes and namespaces. Okay? So as you go with the namespace, you put scope resolution. It's the same thing. So you are saying, I am in the draw of the bar. I want you to call the draw of the line that is the base one. So it's going to call it. We good? Okay? So this draw overrides the draw at the top. Okay? And that's that. You okay? All right? All right. So, having said that, now that we understand the syntax for inheritance, let's talk about animals.
Professor, I have a question.
Yes.
Because we said class bar.
Wait. Okay, class bar.
Line 28. Yep. We said public there. Can we set private or is on way either?
Not even OOP244 NBB. Okay, so this public thingy over here, the second one, tells how the derived class can access the properties of the first one. When you say public, it means everything as is. Anything that is private over there will be private over here. Then we have a protected one. When you say protected, it means you have bad design. You should never have protected. Why? Because the sky is high. Just know it. It's too rich for your blood. When it says class bar private line, it means I want everything over there it means I want to look at that privately. Okay, so just keep it that way. So it's very tough thing. I don't want to go through it. Let's just just remember, for us, syntax of inheritance is public. That's it. We have nothing else. Okay, all right. We good? All right. Okay. Anyone else? Any question? There should be a set as a startup project. There you go. So in here, I have a class called animal. The class animal. I designate an animal. I encapsulate an animal of a being with a name that can be created with a constructor. Forget about copy constructor and copy assignment. I just created this so you can put messages in it and see what it is. I don't have any resources outside of the class, so these two are garbage. Don't look at them. We don't need them. You only need copy constructor and copy assignment when you have resources outside of the class. Everything's inside, so forget about it. Okay? We good? All right. This is a query to get the name. This is a modifier to set the name. Okay? So I can set and get the name of an animal. We good down to this point? You okay? Also, you can actually set it using the constructor. an animal can act, an animal can move, an animal can make a sound. And I have a destructor in an animal too. Again, we don't need it, but I'm putting it just to show you what happens in inheritance. So we have an animal in our house. You good? Are we okay? And how does an animal actually work? It's pretty straightforward. There's no extraordinary thing over here. Why did they change this? How do I do left and right? Oh, there we go. So as you see, I have something over here called debug. Now debug is actually a global variable that I have in the utils. So in utils.h, I have created, so as you see in here, you see it says extern utils ut and extern boolean debug. Extern for a variable is like prototype for a function. You write a prototype for a function in a header file, you can use that function everywhere, right? Now, if you have a variable in one file and you want to use it everywhere, you extern it. So essentially, I'm writing a prototype for the UT class, that is my utils class, and I'm writing a prototype for my debug boolean so I can turn it on and off and turn on my messages and turn off my messages. And these two are defined in my utilities. So if you look at the utilities over here, in utilities, I have utils UT, so it instantiates the UT class, and I have Boolean debug, it creates the Boolean. And those two extern, whoever includes utils.h can have access to debug and UT. We good? Are we okay? All right. So essentially, that extern makes a file scope variable a global one. In IPC 144, they told you if you write a name of a variable at the top of all the functions, it becomes global. That's a lie. It's not global. It's only visible in that file. If you create a second file, you can't access it anymore, right? To make that file scope variable really global, you extern it. You create a prototype for it. Anyways. So as you see, the debug thingy over here says creating name. It actually says if it's copied or not. And the destructor over here says destroy, okay? And my main over here, please run it at home. It's gonna create an animal called Fluffy. It's gonna tell it to act, move, make a sound. Then it's gonna pass an animal by reference. Take the reference out, you'll see copy constructor is gonna get called everywhere, okay? And when it dies, it shows which one is dying. So it's just a class, right? So please run it and you see what's going on. Just gonna run it to see if it runs or it's going to, well, build errors. No, what? Oh, I have to retarget. I'm not gonna retarget it. I have to retarget it. How do you retarget? There should be a retarget. I see retarget over here. Top. Oh, retarget project. There we go. Apply. Hopefully now it's gonna work. So then you have to retarget it back again. You know that, right? If you are using 2022. Let me see if it runs. Come on, didn't I retarget it? One more time. Retarget. Animal. Oh, retarget to platform. I think I should install missing platform. Do you think it's going to take too long? Let's see what happens. Give it a second. Oh, no. That's going to take forever. Forget it. Sorry, I don't have the 2022 over here. I just wanted to retarget project. Yeah. So now Control F5. So it's just going to run it and go through it, hopefully, and everything's going to be fine and dandy. And it's going to show you that creating Fluffy the animal and yada yada end of main. but if you actually make the debug debug is true. So it's actually showing it. If you make it off, it's going to turn off. And if you remove this one and remove this one, then hell is going to break loose, which means it's going to get calling copy constructors all over the place, and that little thingy that you have will change to this one. Right? It's just going to, we're good down to this point? Please run this at home and go through it and see what it is. Turn it to on and off and yada, yada, yada. Okay, so that's that. So now that we have an animal, set a startup project and retarget. Maybe it's even better for you to install 2026 now, because you can always retarget everything that you see over there to 2020 from 2022. Now, take a look at the thing. Now that I have an animal, I want to be able to have a cat. So if I want to have a cat, what is a cat? Cat is nothing but an animal with number of lives, right? That's the only difference. So I'm going to say a cat is an animal with number of lives. Now I create the exact same way I created the constructors. Let me show you all the good stuff. And the animal doesn't have that copy construction thingy anymore. So I removed that one so you can see. And we added one more thing over here called protected that you haven't seen before. What is protected? Protected is your father. Like, let's say you live with your parents and you're 16 years old, 17-year-old, whatever, and your father has a Porsche 911 and has a Ford Festiva, okay? Porsche 911 is private. You're not allowed to drive it. The Ford Festiva thingy, the $2,000 car, that's protected. It means all family can drive it. But because it's protected, your neighbor cannot pick it up. Protected means within the class only, and it's inherited stuff. So an animal who has a protected anything, that protected thing can be called by the derived classes, but no one else's. Private ones, private to everyone. That's the Porsche 911 thingy that is an antique and it's going to be very expensive. So they're not going to let you. Okay, we good down to this point? Public is public. It's everybody can call it. The derived classes can call it and everything. Protected, accessible only to derived classes and no one else's. Private, accessible to no one. We good? All right. And why did we do that? So the cat can actually set the name. If I didn't do that, then cat could not set the name, right? And I didn't want anyone else to do it. So now if I actually look at the implementation of these, as you see over here, now I have the constructor over here that is initializing number of 9s to 9, as you see, setting the name to Garfield. Okay, so if you create a cat, the name's going to be Garfield. If you don't know who's Garfield, it means you're young. Okay, if you know what's Garfield, it means you're 60-year-old like me. Okay, so Garfield used to be a comic character for a cat. Anyways, so, and if you actually are debugging it, it's going to tell you that it's defaulting it. Okay, now for the constructor, I'm going to say cat has a name and number of lives, and I'm setting the animal to the name. So I'm actually in here, I'm not mentioning how the animal is going to get created, so it will be defaulted. In here, I am actually telling the animal will have the name and the number of lives will be that, as you see over here. Or, so what I'm doing in here is some fancy stuff for validation. So this is lazy evaluation. We talked about it in class, right? Did we talk about lazy evaluation? Lazy evaluation? No? Okay, so we didn't talk about lazy evaluation, so let me remove that. So just to let you know, this means if number of lives is greater than 9, then if number of lives is less than 9, then it's got to be 9 out of them. But yeah, but so what we're not gonna do that. We're just gonna put. No, lazy evaluation you haven't done. So I'll explain it to you later. So remind me next time what is lazy evaluation. I'll mention it. So what I'm going to do in here, I'm going to say number of lines less than 1. Now we have nothing. It's good. Now it's not lazy evaluation. That's perfect. Okay, so if number of lines is greater than 9 or less than 9, then it's 9, otherwise none. We good? Okay, so it validates it. Now, and debug is actually debugging it, and we are good to go. So let me remove these things we don't need it. Remember this? Common mistake, don't do it. Don't call a constructor. A constructor cannot be called. Especially in inheritance, they make a mistake to call because that happens in Java. In Java, you can actually do that. You call the super, right? In here, you can't. People by mistake call the constructor to initialize the animal part. But what actually happens, it creates a temporary nameless animal and it dies immediately. It has nothing to do with that one. You have to put it in the initialization area, okay? The acting is overriding the act of the animal, and it acts like a cat. We did not implement the move, which means when you tell to an animal to move, they all move the same. It comes from the parent. And we override the sound and use the animal sound in there. So 3 different types of override. An absolute override that completely overrides the parent, not implementing anything, which means always the parent will be used, or override the parent using the parent's action in here to add to its capabilities. And also we add a feature that doesn't exist in the animal at all. Animals don't play. Yeah, well, I'm just coming with stuff, right? And then destroy the cat. We good? Are we okay down to this point? So looking at this, if I go to my main, this is what happens. Now, I create an animal called Coco. So let me just close this. And let me start it. Did I set it as startup project? Yes. So I'm creating an animal. It has nothing. Because animal is inherited to cat, animal itself has no idea about it. Don't think because an animal is inherited to cat, something special is going to happen to animal. When you create an animal, you should not even consider that a cat exists. Remember that. Inheritance is always when something is inheriting from a base. If you create the base by itself, then you don't need to worry about anything. There is no inheritance involved. Overwriting the name, empty. Let me make this a little bigger. Okay. Now it's creating. When I create Fluffy, it actually creates Fluffy the animal and then sets the life to 5. So as you see, the animal is created and then cat over it. If I just default a cat, then the animal will be defaulted and the cat will be created and the name will be overwritten by Garfield and defaulted with 9 lives. You okay? That's what the messages are good for. If you set that to off, nothing happens. You don't see any of those. I'll show it to you. Now, I keep telling you, please do not call me Mr. Soliman, okay? My name is Fardad. My last name is Soliman. Actually, my father was a teacher too. He used to teach mechanics. Yes. In object orientation, that's the funny part. If you call me Mr. Soliman, I'm going to start teaching mechanics. Now, this is the way the thing is thrown, and we'll go with the degree of the projectile and so. Well, anyways, what I'm saying, yes, yes.
Did your father teach high school or college?
Military.
Military?
Yes. Anyways, forget about it. Please, we are teaching C++. That was just an example, okay? Okay. So ordnance, they used to call it, transportation. Anyways, so what I'm saying is that in object orientation, that's the case. If you call a child using the parent, it forgets that it's a child. So if I create a cat, hold the cat reference in an animal, I can. Because a cat is an animal, therefore it could be referred to or pointed to as as an animal. I can have an animal pointer point to a cat, no problem. I can have an animal reference and make it the new name for that cat. But the problem is that if I use that, then the cat is gone. I only see the animal part. So when I do this, obviously nothing happens because it's just a reference being created. But when I say G act playful Garfield the cat, but when I say AG cat, that is the reference, it's just an animal. It forgets that it was Garfield the cat. Got it? Do we understand this? So when you override a method in inheritance and you look at the inherited object using the base pointer or the base reference, by default, all the methods of the base will be called. It's not even aware that a child exists unless 3 dots. We will find out later, okay? We don't have an unless at the moment, okay? So it's going to act, move, sound, play. Please go through it. You'll see that. And after everything is done, everything's going to die afterwards. We good? This is inheritance down to this point. And we did that with the utils, with the bar and a line too. So the next day you are coming, you're going to have a quiz. You know that, right? You're going to have a quiz, and we're going to have a lecture, okay? So be on time for a lecture, and then at the end, right at the end, we're going to do the quiz, so you finish and you go, okay? I'll try to make the quiz very short, so you need around 20 minutes to do it. It's not going to be a long one, okay? So down to this point, we're just fine. Answer.
Will we ever have a quiz where it is multiple choice?
Yes, only in midterm and final.
Oh, only midterm and final.
That's it. No quiz. Quiz, you always write programs. Why do you need a multiple choice? What is this, geography? You need to learn how to program. Why do I have a multiple choice?
For the final, is it going to be the same type as the midterm where 35%?
Is it going to affect the topic of inheritance now?
No. I'm just curious.
Shush.
Aye, sir.
Okay, whenever I say any questions, then you're going to say that. Okay, I have 3 minutes to go through this. Give me a second. So we're going to go through the third one. So first, retarget. Retarget. Why can't I? Okay, retarget to current platform, apply. You have to retarget it back and set as startup project. This is using the exact same thing with one difference. Everybody close your eyes. Actually, I can do this. You don't need to close your eyes. We're good. You don't need to close your eyes. Okay. Exit blank screen. Okay. All right. So there's only one difference over here. It's exactly like the other one. The difference over here is that I have an animal pointer. This is the part that's going to cause humongous amount of trouble. Okay? Look, P is Pepper, correct? It's a cat. P is Pepper, is a cat. I have an animal reference to P, which means no new object is created. This is just a reference to cat the pepper. Pepper the cat, okay? Are we good down to this point? But for this one, line number 9, I am having a pointer, and inside the pointer, I'm creating a dynamic cat, and I call it Tom. Got it? So there is no cat reference to that cat. It has only one handle, and that's an animal. You follow? What happened? Cat P has two handles, a cat and an animal. It's created originally as a cat. It has an animal handle too. Line number 9, cat. Tom the cat does not have an animal handle at all, cat handle at all. It's only referred to by an animal. And I have an animal symbol, which we don't care because it's an animal. When I write animal, it means forget about it. There's no inheritance, just an object by itself. We don't care. Are we good down to this point? Okay. Obviously, when I run all these beautiful stuff, cat is created, another cat is created. So I created 2 cats. The other one is only references by an animal. Nothing happens over here because it's just a reference. And here now an animal is created. So I have 2 cats and an animal, and Ian is asking a question. What's up?
Can you change the name of the cat into Puss in Boots?
Next session, sure.
I feel like it'll be more fun.
Next session. I have 2 minutes and you're interrupting me. Shush. Okay. So now I can say P cat, and act. Pepper's going to act. Pepper's going to move. Pepper's going to make a sound. Right? If I do animal reference, it turns to an animal. Cat disappears. We understand that, right? Now for the AP animal pointer, I don't have an access to animal at all, to cat at all. It's only an animal. So there is no way that I can get the cat side, even though I created it. So first problem, although a cat created in the animal, I have 0 access to it. It's absolutely useless. Down to this point, no harm. It's just useless. But see what happens over here. So now I am deleting AP, animal pointer, correct? When it's deleted, what's going to get deleted? It goes to animal, deletes the animal. What happened to the cat part? It didn't get deleted. Memory leak. When I create a dynamic instance of an inherited object in the base class's pointer, when I delete it, I'm going to have memory leak because compiler has no way of knowing that this is not an animal. It's a cat. So it deletes it as a cat. For the rest of the stuff, life is beautiful. I have no problem. So when this is actually called, the animal is first removed, and then after the animal, the cat is removed. So for every single one of them, everything's good. So as you see, Pepper, first the cat is removed, then the animal. So both parts are gone, no memory leak. But for that one, there is a memory leak. How do we fix this problem? There is a very, very easy solution for it. The solution is to tell to the compiler, hey, what you are dealing with now is not a regular class. It's a base class. So when you are actually dealing with the pointer of reference of this, always check to see if there is a newer version referred to. If that's the case, use the latest version, not this one. How do we tag that? Like this. I can go to a header file. If my class is designed to be a base class, I'm going to say the destructor of this class is a virtual one, which essentially means this is not the real one. See if there's a new version, call that. Got it? Now see what happens. What's the difference? When I run this now, everything happens the same. So again, act, move, and sound are not accessible, as you see. But when it comes to delete, when you say delete, because the destructor is virtual, it calls the latest version first. So first it kills the cat, and because cat has an animal in its belly, the animal will be gone too. Therefore, no memory leak. And the rest is the same. Got it? So as of this moment, till end of your life, whenever you are creating the class, just to be in a safe side, the destructor must be virtual. If anything you create from this moment on, the destructor you are creating, you don't have a virtual tag in front of it, you get 0 in it. To make sure that if in any moment of time this class is derived by another class, and make sure that memory leak doesn't happen in dynamic memory allocation, the destructor must be virtual. If you just create the animal, it doesn't care if it's virtual because no inheritance is involved. There is no newer version. But if there is a newer version, that's going to be called. We good? You okay? We are good. All right. The next day we are coming in, we're going to get into the real type of polymorphism, virtuality. I just told you what the destructor is. With the next time we come, we're going to do a review and we'll go to more stuff. Chen, you have a new thing to work on. You know that, right? All right. We good? Are we okay?
So, to make the destructor virtual, you just have a virtual.
Just write it at any moment of time. You're writing a virtual, you're writing a destructor, you write virtual, and then you write the destructor. Always.
So, like the class name virtual destructor.
No. Virtual, tilde, class name. All right. So that's that.
Thank you for your class today.
You're welcome, and thank you for coming to class today. 10% for final because of being in this class. I am joking to the bone. Okay, so let me just commit this. Toward this git, commit. The next day you are coming in, the night before, sleep and come with coffee because you have to be alert. I'm going to teach 3 weeks worth of material in 40 minutes, okay? You need to be alert, okay? Thank you.
3 weeks worth of material in 1 week?
In 40 minutes, yes.
How is that possible?
Because if I don't do that, you're not going to learn it in my experience. So I have to do that, and then we're going to repeat and repeat and repeat and repeat. All right.
See you on Wednesday then.
See ya.
I hope you get better.
Yeah, I hope so too. Oh, I hope so too.